without further ado, I'll get started. So, hey everybody, my name is Emmanuel Schanzer. I am the founder and co-director of an organization called Bootstrap. We've been around for about 15 plus years now, and our specialty is integrated computer science. And so that's what I'm here to talk to you about. And specifically, we're going to focus on this new data science thing. That's sort of the big trend. So I'm a former professional programmer. I left the tech sector to pursue a passion for teaching, got my start as a Boston Public School math teacher. Foolishly went back to grad school to get a doctorate in algebra and computer science education. And for the better part of a decade, I've been a math and CS ed researcher at Brown. So for those who may not know, just a sense for like what Bootstrap is all about. So we are one of the largest providers of computing across the country. We reach more than 30,000 students every year. And while we're happy with that scale, what we're most proud of is our diversity. So 43% of Bootstrap students are girls and young women, 46% self-identify as being African-American or Latino. And if you're familiar with what these numbers usually look like in computer science, you know that these are sort of extreme outliers. And I'll tell you a little about how we got to have this level. And spoiler alert, it's all about integration. So 15 years ago, everybody was talking about CS for all, right? Computer science for all, it has to be CS for all. And everybody was asking, at conferences like this, what should these classes look like, right? What should they be? What content should be taught? Who's going to teach them? Where do they fit in the schedule? And we made a really controversial bet at the time. So first we said, we don't think siloed computer science classes are the only way to do this. In fact, maybe they're not even the best way. Then we decided if we're going to try to figure out how to do this in a non-siloed way, we have to integrate computing and other subjects, especially math, in an authentic way. So when I say authentic, I don't mean tell the math teacher to find an extra 2 weeks in the middle of their year to just teach some random programming. No, I mean actually weave the two together so that the math and the computing become mutually reinforcing, and do it in a way that does not ask that teacher to find new time in the schedule that isn't already there. And finally, the last part of our bet was, can we pull this off in a way that's equitable for all students? So fast forward now 15 years, right? So now we're one of the biggest providers of in-school CS. We're one of the most diverse. And the reason we get the numbers that I showed you in that first slide is that we're working with the teachers that already reach every child. So when we talk about algebra, for example, every kid takes algebra. And so if we're working with those math teachers in their regular math classes, that's how you get to equity, and that's how you get to scale. So we've been really thrilled with this success. We're honored to be one of 3 curricula explicitly cited by the National Science Foundation. And I think what we're most proud of is that most Bootstrap teachers are not computer science teachers who have no computing background, and they're doing it in non-CS classes. So that's sort of our background and history with respect to computer science for all. But we're not really here to talk about computer science for all, right? We're here to talk about data science for everyone. That's the new thing. And surprise, surprise, everybody's asking the exact same questions about data science that they did about computing 15 years ago. They're saying, what should these classes look like? Who's going to teach them? What content is there? And where do they fit in the schedule? So history is repeating itself. And I'm here to talk to you about why integration is so critical. But what is data science, right? When we're talking about data science, what do we actually mean? Well, I like to think of curriculum design as sort of like baking, from a recipe. And recipes have sort of core ingredients, but everyone makes theirs a little bit differently. So, Terry, when he bakes a cupcake, he might put a little cinnamon in his frosting. Susan might do sort of like shredded coconut on top. Dana here might have like a filling for her cupcake. Everybody messes with the recipe a little bit. But the thing about recipes is that if you leave out a core ingredient, whatever you bake might be delicious, but it ain't the thing you set out. So if you decide, hey, I'm going to make a cupcake, but I'm going to skip the frosting altogether, well, what you have might be delicious, but it's not a cupcake. It's just a damn muffin. So what are the core ingredients of a data science class in K12? Well, the loudest voices in the country right now are basically all in agreement that data science is 1 part statistics and 1 part computing. And if you mix them together, boom, you've got yourself some data science. Well, I'm here to tell you that this is dead wrong, if not dangerous. So think about it this way, right? The proposal is we're just going to take some statistics. So thank you, R.A. Fisher from 100 years ago. And we're going to add like a little bit of Python and then voila, data science. Consider a great computer science class where kids are doing all kinds of like, object-oriented programming, and they're thinking about algorithms, and they're making video games and all this stuff. And then at the very end of the course, the last 2 weeks, the teacher tells them, here's a TI-84 graphing calculator, right? Here's the buttons to press to compute the standard deviation. Boop, 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 boop. And the kids just sort of memorize what buttons to push. Now, this is not a data science class, right? You can't shove a little stats at the end of a coding class and call it data science. So we can all laugh at that and say that's silly. But I think not enough people are laughing and questioning the proposal that we're going to take a math class and then add 2 weeks of Python at the very end and call that data science. It's just as ridiculous in either case, right? Students learn a bunch of stats. Now they learn what commands to type into Python. Boop, 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 boop. Is that data science? Absolutely not. So just combining these two ingredients is a lot harder than many folks in the country right now are claiming that it is, right? They're just taking math classes and bolting on some coding. We have a different approach, right? And this is what we learned from our last 15 years in algebra, that the two need to be woven together and mutually reinforcing. But I would argue that there's actually two more ingredients that are being left out of the conversation altogether. So yes, there is some statistics, right? You need to understand what the math is telling you when you do your analysis, right? Without statistics, you just get like, histograms full of zip codes or other nonsense. And you also need some computing, right? There's an element of computational thinking that's necessary for data science, whether that takes the form of programming or playing around in spreadsheets, but that's where you get the rigor. That's where this differs from pure math. But it's not enough just to teach those ingredients. So we would say that another key ingredient here is civic responsibility. And here's what I mean by that. If you think of data science as nothing more than math plus code, well, then, okay, great. You'll do a good job telling your students about why it's so important to take a random sample, right? Random samples, that's what we need. But when you talk about data science, it turns out very often we build data models by taking random samples from a population that is littered with bias. And there are real life examples of this happening right now. So there's software programs that have been built using historical data to recommend, minimum sentencing for people who are convicted of a crime, or that recommend whether or not a patient should be approved or rejected for certain pain medication. Now, given that historically this country does have a little bit of a problem with racism, just a scooch, the end result is that we've now encoded that racism into our algorithms. And these algorithms are now repeating that bias when it comes to things as critical as minimum sentencing or receiving medical care. So the only way to address this is to talk about civic responsibility. It's not just about the algorithms and the code. And look, we know this from experience. What happens when you teach medicine without civic responsibility? You get the Tuskegee experiments. And what happens when you teach data science without it? Well, we're seeing some of that now. We're getting Cambridge Analytica, weaponized social media, hyper-targeted redistricting that results in greater polarization in our society. So this ingredient of civic responsibility has to be part of any responsible K12 data science course. Finally, the other ingredient is domain investment, right? Students need to know something about the data they're analyzing. You could be the best mathematician and the most brilliant programmer in the world. But if you don't know anything about baseball, the Red Sox are not going to hire you to analyze their data set. And this is what it means when we talk about integration. So for all of you that are tuning in right now, we literally cannot teach responsible data science in a vacuum. If you're analyzing climate data, well, then you need to make sure that the teacher and the students and the class itself have some focus on environmental science. If you're looking at data about a ball rolling down a hill and you're trying to get acceleration discussed, it's got to be a physics class. You literally can't do data science without investment in the domain. And this has implications for everything from engagement and equity, right? What happens if a teacher tells their students, we're going to analyze all the greatest vineyards in Tuscany? Who feels left out? Which students feel empowered by that, right? So there's equity and engagement, but it also has to do with mastery. So without targeting as a specific domain for your data set, this isn't going to fly. And that's why I'm going to make a fairly strong statement. At Bootstrap, we try to balance all of these ingredients together. And if you don't balance them, if you try to teach data science as a standalone class, and I just want to point out, most of the folks in this country are talking about adding a new class called data science. I'm going to say, we think at Bootstrap, this is potentially harmful. So how come? First, not every school has the resources to add a whole new class, right? They don't necessarily have a teacher sitting around twiddling their thumbs, already drawing a salary, ready to teach this class. Nor did they have empty rooms or empty computer labs. So we have to find room in the schedule and room in the budget to add this new class. And that's going to leave some schools and some students behind. Second, suppose we do add this class, right? Suppose you're one of the lucky schools that can add a whole data science class. Well, is it going to be an optional elective? Because if that's true, now you have to worry about which students opt in, right? Because opt-in data science competes with opt-in theater, opt-in AP physics. And in some schools, it competes with things like opt-in, take care of my little brother, or opt-in, leave school early and work my job. So electives introduce a dangerous equity gap, and we've seen already how that's played out with computing. We shouldn't repeat mistakes of the past. Now, the other option, of course, is to make this new data science class a graduation requirement. But the moment you do that, that means that there's a perverse incentive. No teacher wants to be the one who fails a kid who was about to be the first in their family to go to college. And so as a data science teacher, if this is the new requirement, there's some incentive to really make sure that it's not necessarily that challenging of a class. And I think we've seen that play out as well in computer science. So I'm not saying we can't do standalone data science. I want to be really clear. There are some fantastic programs out there that are kicking butt at this, and there are some wonderful schools that are doing a great job. But my point here is that standalone data science is a lot harder to implement than people are saying, and doing it wrong can be problematic. So there's another solution we should be talking about, which is integrated data science. Not only does it not suffer from any of the flaws of standalone classes, right? It's in the classes that everybody takes, so everybody gets access to it. So equity is built in right from the start. But what's so much more important, and this is where these two ingredients come in, is look, domain knowledge, given how important domain knowledge is, this essentially requires that it be included in the non-math and non-CS classes as well, right? If you're a social studies teacher and you want to talk to students about maybe, I don't know, like the long-term impact of redlining on African-American wealth and home ownership in this country, well, that's a great data science topic, and there's easily available data to explore it. But only a history or social studies teacher is going to have the skills and the content to have that conversation productively. I don't think a lot of math or CS teachers are ready to get there. And the few that are, kudos to them. But frankly, it's not fair to demand that the math and CS teachers, who already have a lot of content to teach, have to cover this other stuff. And that's just one example. So domain knowledge means we need all players involved. And civic responsibility, same thing. When we talk about data science, if we're doing it responsibly, we got to consider things like ethics, privacy, and bias. Are the math and CS teachers the best ones at the school to talk about these issues? Some of them might be, but it's not just them. And this is where all teachers need to be involved. So what does this actually look like? Well, in a science class, you could have a biology teacher collect data on plant growth, right? Maybe some plants are getting UV light, some plants are getting infrared, and students are gathering data. This is something bio teachers already do. Well, that data can now be analyzed using data science tools. A physics teacher can have their students track the progress of a ball rolling down a ramp, right? So every meter they have a little stopwatch. And the goal is to teach students about acceleration. The way physics is taught right now is that we give students the formula and then we do an experiment to back it up. But like, how important is the experiment and how important is the data? If the kids don't follow the experiment, they still have to learn the formula. By integrating data science into your science class, you can flip that. You have the students start with the experiment, gather their own data, and then analyze it for trends. Does the scatter plot for that ball look like a straight line, or does it seem to have a curve? Once they've analyzed the data, students are that much more interested in finding out what the formula really is, and they're 10 times more likely to understand why. Rinse and repeat for chemistry. Teachers can measure the change in freezing point as they add salt to water. An earth science teacher could have students, look at the relationship between temperature and rainfall. All of these topics involve gathering data and analyzing it for trends, and they're all things that science teachers already do. All that's needed is to add a thin layer of teaching students how to use the tools they need, and I'll get to that in a moment. And all of a sudden, we can unlock the potential of data that's already in our science classes. What does this look like in history? Well, you have a US history teacher look at the economic boom that followed World War II, right? If any of you have opened up a history book, you'll notice that every 10 pages, there's like a chart, a table, or a graph. So the history books are already full of data. But let's flip the script, right? Because the way that history is traditionally taught is you open the textbook and the book just tells you the story. It tells you what happened. Whereas actual historians, they don't have a textbook. They have to look at data and try to figure out what the narrative was. So if we started with the data, the teacher in US history could, instead of telling kids about the boom, have them look at the table and ask them, what does this table tell us? What was really going on after World War II? And when the students get attached to the narrative, now all of a sudden they're invested in finding out what the book says. Rinse and repeat. A European history teacher has their students track population levels during the Black Plague. You want to get a real appreciation for the scale of that plague? Well, you got to look at a line graph. I mean, it's absolutely shocking. But without looking at the data, it just becomes, a story in the book. Oh yeah, a lot of people died. So we can teach history better by rooting it in data, because that's exactly the way historians do it. World history, same thing. Have students compare trends in immigration. Now, I don't know if we have any history teachers in the room right now, but I will say that there's a huge conflict happening right now in the history teaching movement, which is about the power dynamics of the fact that the people who win tend to be the ones to write the history books. And so there's this question that history teachers have, which is, how do I teach my students what's in the book, but also give them a healthy appreciation for the fact that there might be multiple narratives in play beyond just the one in the book. Data science is an ideal place to do this because the data can support multiple stories. And this is grounding as well, because we're not telling kids like, oh, any story is equally good, right? Some stories are not supported by the data, and so we don't really believe in them. They don't seem true. But there are places throughout history where the data could support 2 stories or even 3. And students arrive at this naturally when they're analyzing the data set. So by doing that, they're getting a more authentic exposure to history. They're learning the narrative in the book better, but they also have a healthy degree of confidence that they understand how to be critical thinkers, and that maybe the story in the book isn't always 100% accurate or isn't always telling the full story. I want to share a case study. So Bootstrap partnered with the KIPP charter schools up in New York City to design an elementary grade data science module for their history and social studies course. So students explore data on shipwrecks, pre-colonial settlements, etc. And the beauty of this is that these teachers, they have to teach this content anyway, and they already have a scope and sequence. So they have a sense for how long it takes to talk about, what life was like in pre-colonial America. Well, we've provided data sets that are, the result of archaeological digs, for example. So we can find out what was found at these settlements. Were there lots of cow bones or sheep bones or chicken bones? What kinds of tools were found? And so before students read the story in the book, they actually look at a spreadsheet of this data and they start to generate their own guesses, right? Is the fact that there were lots of sheep bones, does that mean that they were eating a lot of sheep? Maybe, maybe not, right? Maybe there was a disease that killed a lot of sheep and that's why there's all those bones. And so the students are starting to argue with one another, right? I think the data supports this. No, I think it supports that. And the engagement is so much higher because the class is open, right? They have the opportunity to make their own meaning before they look at the book. And of course, when they do, they're that much more engaged and their retention of the history content is that much higher. And so we're able to do this in non-computing classes with teachers who do not have a computing background without having to find room in the budget for a new teacher or room in the schedule for a new class. And that's happening right now across New York City with elementary school students. In social studies, we could look at voting data, population shifts, the difference in representation between the Senate and the House for urban and rural splits. We could look at the change in demographics nationwide over the last 50 years. There are some major changes. What does that mean for equity? These are things social studies teachers already talk about. and the data is readily available. So we're so close to being able to use it, it seems nuts to take the data science and silo it away in a different class. Even in a business class, right? Business teachers have students track sales data. They look at the stock market. They explore earnings reports of actual real life companies. Well, rather than reading a newspaper article about it, or trying to look at a table or a spreadsheet and argue about what it's telling you, what if students already knew how to build a scatter plot and how to do a linear regression? What if students already knew which visualization made sense? All of a sudden, that business class becomes much more applied and frankly, much more relevant to the kinds of skills students are going to need in business moving forward. You can even have phys ed teachers work with data science, right? So phys ed teachers are tasked with a number of things, right? Talking about the importance of nutrition and exercise, improving students' skills in specific things like whether it's free throws in a basketball court or sprint times around the track, right? It's easy for students to gather data on what they're doing, what they're eating, and analyze it to find out, well, gee, when I sleep more, my sprint times are actually better. Or maybe, the amount of, what the food that I eat seems to have an implication for my free throw percentage. Now, it's easy for me to give these examples, right, to toss them out. And you may be sitting there thinking, okay, that sounds cool, Emmanuel, but where do these teachers find the time to actually, teach the data science stuff? And this is relevant, right? Because if data science is difficult to teach, if it's a heavy lift, then integration fails. Because those teachers have the least amount of time to teach new stuff. So before I dive into that, I just want to return to this discussion of computer science and point out, because many of you are here because it's a computer science conference, that computer science itself needs to address data science. First, data science is not just about writing code. It's about making meaning. It's about making sense. It's about being ethical in how you disclose your analysis. These are topics that are often left out of computer science courses. I'm not saying that everyone leaves them out. There are some great classes and great teachers that do it right. But there are a shocking number of computer science courses that are literally just about code. Data science makes that impossible. So by integrating data science into computing standards and into the computer science we teach, as educators, we force ourselves to have the more important conversations about what this stuff means. What's the impact on society? And sometimes those impacts are easier to discuss when you're talking about, I don't know, an algorithm that tells police which people to stop and frisk versus an algorithm that doesn't. Computer science also talks about cybersecurity, but in most cases, this is 30-year-old material, right? We tell kids, what are the components of a strong password? Don't share that password with anyone. Okay, it's 2022, nobody cares. A responsible cybersecurity class nowadays needs to explain to kids why they need to stop filling out those surveys on Facebook so that will tell them which Harry Potter character they're most like. And that's a data science topic. That has changed the way cybersecurity needs to be taught. Then we talk about rigor. Computer scientists love to talk about rigor, but often we just have kids write code and if it runs, I guess it works. That can fly if you're making, a video game. Yep, the game seems playable, good enough. But in data science, that doesn't fly at all. Just because you plugged in some numbers and the computer spit out a histogram does not mean that your histogram makes sense. It does not mean your histogram is valid. And it does not mean that the sample of data that you're graphing even makes sense to graph as a histogram. So integrating data science into computing also helps beef up the amount of rigor that we always know we wanted our kids to learn anyway. Finally, working with structured data, right? Kids learn really quickly that if you have a table of data and it's got some blank cells, or it's got a mix of numbers and strings, they can't run their analysis. This is, thinking about structured data and data integrity are foundational concepts for higher level computing. And instead of having to teach, object-oriented programming in Java, we can introduce it in a gentler way in an intro class through data science. So even in the CS world, data science has something to offer. So what does this look like, right? So I'm going to give you sort of a bird's eye view for how we think about data science in K12. And this is where I'm going to talk about the tools, right? I said earlier, the devil's in the details. If these things are difficult to teach, no one is going to integrate them. So at Bootstrap, we think of curriculum along 3 axes. What are the things we want kids to learn? What projects do we want to empower them to create? And then what are the tools that are appropriate? Well, at the elementary school level, we think the key is visualization, right? This is where students can start making charts and graphs. And look, am I saying that we want third graders making scatter plots? No. There's a million beautiful ways to visualize data, right? You can have students do completely unplugged activities with everything from stickers to markers to puff pens or whatever you want, where they're looking at some data and they're actually making an infographic. And teachers can talk about data with students at the elementary school level and talk about the difference between displaying numbers that have some kind of order or displaying categories that don't. Some of our teachers at KIPP are doing this right now with elementary school students in New York City. So a great project for elementary school teachers is simply having kids make an infographic. And you can do this in any class, right? In any activity. So if you're a fourth grade teacher and your students are going outside to collect different leaves or flowers, and then they sort them, right? How many dandelions did we find? How many leaves did we find? How many acorns did we find? And you can have that conversation with students. Well, how could we explain this to somebody else? Maybe someone who doesn't like numbers. What kinds of pictures could we draw? And this is incredibly fun for kids. It requires no computing whatsoever. For upper level elementary school students, we think it's appropriate that we include spreadsheets, right? So we support unplugged and spreadsheet activities at the elementary school level. Middle school is different. Our learning goals in middle school, there's some statistics that we want students to focus on, right? This is where the standards for middle school math, they cover things like measures of center, mean, median, mode. They absolutely cover everything from pie charts to bar charts to box plots and histograms. So the kids are going to see that in their math class. And if the math teacher wants to do data science, mazel tov. But the fact that they see it in their math class means other teachers, non-math, non-CS teachers, well, we could actually do some cool stuff with that. So we could do different projects. We could have students collect their own data and then report back using what they learned in their math class. We could talk about this as, let's say, a survey of our fellow students at the school to find out what's stressing them out. What do they like? What do they dislike? This is something you could easily do in a social studies class, or you could easily do in a business class or a history class or a science class where they collect the data and then they have to display like what did you learn? Another really interesting thing you can do in middle school, because at the middle school level, we talk about mean, median, and mode and how they're quite different from one another. So for example, if the data set is really skewed, like income in America, and you've got Jeff Bezos way off to the right, well, then you shouldn't be taking the average because Jeff Bezos throws off the average income. He's such an outlier that it's irresponsible to use average when you're talking about income. That's where you want to use the median. Well, we can teach middle school students. We do this project in our curricula. We call it fake news. Another way to describe it is lying with data, where you basically show students some data and then you show them a conclusion drawn from that data. The data has to be accurate. The conclusion has to be statistically correct, but it's slimy as all get out, right? So for example, the average American earns $43,000 a year. That's well above the poverty line. Therefore, very few Americans are living in poverty. That statement is a totally slimy statement, but it's true. The average American does earn that. This is an activity that our students love, right? They love being handed a piece of paper that has a bunch of lies on it, but they don't know why they're lies. And their job is to use the statistics they learned in math to figure out why it's slimy. To use, maybe we shouldn't be using a pie chart for this. Maybe the pie chart itself is misleading. We should be using a bar chart instead. This is something 6th, 7th, and 8th graders can absolutely do. And they do regularly in our curriculum. Finally, what tools are appropriate for middle school? We think unplugged tools are always appropriate, but we think that Code App is a nice step up over and above spreadsheets. I'm happy to answer questions at the end if you're curious about why I dislike spreadsheets. I think they're fine for elementary school, but we should get kids off of them as quickly as possible. Code App is a nice compromise. It looks a lot like a spreadsheet, but it actually has a notion of tables. And there are plenty of middle school students who are also ready for programming. Finally, at the high school level, this is where we need to be talking about statistics and ethics and programming. So that's our learning goals there. And this can happen in any of these subjects. And if you choose your programming language carefully, it's an easy lift. I think one of the reasons that non-CS teachers are often resistant to teaching CS is that the languages and tools that they're told they should use are incredibly complicated. But they don't need to be. There's no reason that they have to be. And so again, happy to talk more for people who are curious. At Bootstrap, we use our own programming languages that are explicitly designed for learning contexts so that any teacher can do a gentle introduction without having to break out tons of time in the schedule. So that's where our learning goals lie. Our projects, this is where we should be doing original research, right? Students should be finding data, whether it's a data set that's provided by the teacher or collecting their own data and doing real research on that data and publishing a paper. A lot of high school teachers think about portfolios and the need to build student portfolios for applying to college. Imagine if every student that graduated from your school had a portfolio of an original research paper they did about plant growth in their biology class, about population trends in their history class, and about their free throw percentage on the basketball team this year. These are things that we can easily support students doing as long as we take the domain investment seriously and look at integration as a must-have. Finally, when we talk about tools, I'm of the strong opinion that at the high school level, we want students to be doing programming. And again, when I say programming, I don't necessarily mean Java. I mean a real programming language that is appropriate for the cognitive abilities of the student and the data science demands of the project. And these are all things that we're doing at scale. But look, ultimately, if you think data science matters, here's what you need to be afraid of. You should be terrified of anybody calling it new math 2.0, right? If we let this just be a math class or just be a coding class, that's what's going to happen. And we're already seeing it. There's political battles being fought right now in California because there's a rush to put data science in math. We think it belongs in lots of places. And for some schools, math is the right place, but at other schools, it's not. And so the way we talk about data science and the way we message it needs to be broader than just it's a new class and it counts for math. So at Bootstrap, we want to unleash the power of data across the curriculum. And that means all subjects have a place at the table. The tools that we use are always free, and we take a disciplined approach to them. We want to make sure that they're appropriate for the cognitive demands of the student and the computational demands of the task. So in the elementary school level, that means spreadsheets. At the middle school level, that typically means CodeApp or some programming. And in fact, we've even extended the CodeApp tool to build in more power so that students can have a gentle bridge from CodeApp into coding. And then finally, at the high school level, we happen to use a language called Pirate. It's basically like Python, but if you cared about student learning. So it's very easy to learn. The error messages are excellent. It removes a lot of the confusing stuff that trips students up in Python and teachers as well. And all of this is completely available for free. We also offer free curricula for grades 5 through 12. And the team at Bootstrap is interdisciplinary. And we think that's necessary when you address data science as an interdisciplinary challenge. If you have a bunch of programming and math folks sitting around building a data science course, you're going to get a math and coding data science course. But that's not enough. It's not responsible. It doesn't address issues of civic responsibility. It doesn't take domain investment seriously. And you're not going to come up with something that can be integrated across the curriculum. So we design for integration with on-ramps for teachers in every subject at every level. And we're in 49 states serving tens of thousands of students every year. Now this last slide, yeah, I'm talking about Bootstrap, so grain of salt. I work there. Obviously, I think what we do is valuable. But the rest of this talk, everything up until now, this has nothing to do with any one player or any one curriculum provider. Data science has a role to play in all grades and in all subjects. And that doesn't mean everybody has to do it. It just means that we need to leave the door open so that at any given school, we allow the teachers that are interested to dive in. So that's the end of my talking part. You can find all of our material, all of our tools for free on our website, bootstrapworld.org. Happy to chat about data science, pedagogy, integration, and we work all over the country with states and districts to build data science pathways that are right for them. Thanks for your time, and I'll take questions if anybody has them.
Thank you again, Emmanuel. Amazing presentation as usual. Powerful information. At this time, if you have any questions, please indicate in the chat, or you may even come on camera and ask your question.
I see Dana says, do you require training for access to the curriculum? Nope, not at all. We give it all away for free. I will say that the curriculum is written under the assumption that a teacher has been trained. And so, you know, if you're not trained and you want to use it, we're not going to stop you, but you may find it a little bit challenging. But by all means, check it out. Use it as much as you like. And if maybe next year you say, you know, I want some training, we're here for you. Susan says, how do math teachers find the right place in their year to do this? So math teachers already have a scope and sequence, right? They already know which parts of the content they have to teach. So let's say you're in a Common Core state. Every Common Core teacher has those weeks where they know it's their job to do mean median mode. Every Common Core teacher knows, oh, this is the part of the calendar where I need to make sure we're talking about box and whisker plots. We design our materials so that the time we spend teaching measures of center, the time we spend teaching box and whisker plots is exactly the same as the time that teacher was going to spend, so that they're able to integrate it where it belongs. Dana asks, what is the training model? How and when does it take place? I'm so glad you asked, Dana. So we do, typically what we do is we partner with states and school districts. In fact, we've had some good conversations with Georgia Department of Ed about potentially bringing a data science PD to Georgia. We also partner with individual districts. So we've been partnering with New York City Department of Ed for years now, bringing our algebra aligned and data science aligned professional development to their teachers. Every summer, we always do one open access workshop. So I'll paste the link into the chat right now. So this is a virtual PD this coming July. It's for a week. I believe it's July 18th through the 22nd. I'll be running it. And this is open to anybody who wants to join. So you do not need to be part of a partner district or a partner state to sign up. And we're training anybody who's interested, who wants to register. And I'd love to see you there. Link to the slides. Yes, let me do that. All right, here it is.
Any other questions for Emmanuel?
All right, looks like we can let out early.
Let's talk, oh, I think Susan had one more question about places for online teachers.
Susan says, are there places for online to talk to teachers who are already doing this? Susan, I'm so glad you asked. Yes, there absolutely are. So we run a website. It's just a discourse board for teachers who are teaching Bootstrap algebra and data science, as well as our other courses. There's dedicated sections of that site for data science. You do have to register to create an account. It's totally free, but we ask that you fill out a little form to tell us who you are. And once you're in, you can ask teachers about their experience. And I will say, Susan, your check is in the mail. Thank you for asking about this. So Susan is one of our veteran data science teachers. She's an amazing resource. Anybody who wants to know what this can look like should absolutely talk to her. She's here today. You can hit her up and hop in chat or find her on Discourse. Susan, thanks for the reminder.